from Kapalong College of Agriculture, Sciences and Technology, currently taking a Bachelor of Science in Business Administration, major in Financial Management, Section 1B, and today we're going to discuss an important topic about ordinary and exact interest. In midterm topic is all about amount and present value of ordinary annuity, and in the final topic is general ordinary annuity. But before we start our video, please consider giving a thumbs up, subscribe, that bell button to get notification for more videos. So let's get started. Now for present topic, we have to learn on how to compute and what is the meaning of ordinary and exact interest. But first things first, what is ordinary and exact interest? Ordinary interest, or IO, the interest is computed denominator of 360, which gives us a formula of I is equal to P, or principal, times R, or rate, times time divided by 360. While on the other hand, exact interest, or IE, the interest is computed with a denominator of 365, which gives us a formula of I is equal to P, or principal, times R, or rate, times T, or time divided by 365. Note, ordinary interest is greater than exact interest. The answer of ordinary interest is much more greater than the exact interest. When interest is not specified in any problem, it is assumed as ordinary interest.
Find the ordinary and exact interest on 2,750 for 65 days at 4 and 1/8% simple interest. But first, let's find the given, which is given. In P, we have 2,750. For R, we have 4 and 1/8%. For T, we have 65 days. Following the formula of ordinary interest is IO equals PRT divided by 360. For P, we have 2,750. For R, we have 4 and 1/8%. But first, we need to convert it into decimal by solving 1 divided by 8 is equal to 0.125 plus 4 equals 4.125 divided by 100 equals 0.04125. So in R, we have 0.04125. For T, we have 65 divided by it into 360. Next, we just need to copy the P and the R, which is 2,750 and 0.04125. Secondly, we need to divide the 65 divided by 360, which gives us the answer of 0.1806. So, the value of T in decimal form is 0.1806. While in the IE, or exact interest, same as the IO, but we need to change the denominator into 365. 365. So in T, we have 65 divided by 365. And the answer is 0.1781. Just like in the IO, we need to multiply the 2,750 times 0.04125 times 0.1781, which results. If we finish solving for t, we just multiply the p, the r, and the t, which give us the answer of 20.49. So in ordinary interest, we have 20.49. So 20.20. While in the IE or exact interest, same as the IO, but we need to change the denominator into 365. 365. So in T, we have 65 divided by 365. And the answer is 0.1781. Just like in the IO, we need to multiply the 2,750 times 0.04125 times 0.1781, which results to 20.20.
Now for the midterm topic, we have ordinary annuity. Ordinary annuity, an annuity in which the periodic payment is made at the end of each payment interval. Notation: S is the sum of amount of an annuity. A is the present value of an annuity. T is the term of an annuity. R is the rate of an annuity. N is the number of conversion period for the whole term. M is the number of conversion period per year. In order to know what is the conversion number for M, you need to know their conversion number equivalent. Compounded annually is equal to 1, compounded semi-annually is equal to 2, compounded quarterly is equal to 4, and compounded monthly is equal to 12. And I is the interest per conversion period. The formula in computing amount of ordinary annuity is S is equal to RS N at I. The table of values that we are going to use for solving S is table 5. The formula in computing present value of ordinary annuity is A is equal to RA N at I. The table of values that we are going to use for solving A is a table 6. Find the amount and present value of an annuity of 550 payable every end of 6 months for 14 years and 6 months. If money is worth 3.5% compounded semi-annually. But first, we need to identify the given and solve.
The given for this problem is for RS, we have 550. For R, we have 3.5%. For T, we have 14, 6/12. For M, in compounded semi-annually, we have 2. For solving the I for this problem, we need to divide the R into the M. In R, we have 3.5%. For M, we have 2. Now let's solve. 1 divided by 2 is equal to 0.5 plus 3, we have 3.5 divided by 2 is equal to 1.75. Now let's convert the 1.75 into the fraction form, which is 1 and 3/4%. Now for solving the n, we need to multiply the t and the m. For t, we have 14 and 6/12 multiplied by 2 for m. Let's solve. 14 times 12 is equal to 168 plus 6 equal 174 times 2 equal 348 divided by 12, we have 29. So the answer for n is 29. Following the formula in solving the amount is S is equal to RS n at I. The table of values that we are going to use in solving the amount is table 5. For R, we have 550. Now, for N, we have 29. Angle at I, we have I in 1 and 3/4%. Now, we just need to copy the 550 and locate the 29 at 1 and 3/4% into the table of values. We have 37.36, 32, 93. We just need to multiply the 550 into 37.36, 32, 93. So the answer for S is equal to 20,549.81. Following the formula in solving the present value, we have A is equal to RA and at I. The table of values that we are going to use in solving for the present value is table 6. Now, for RA, we have 550. And N, we have 29. At 1 and 3/4%. Let's just copy the 550 and locate in the table of values the 29 and 1 and 3/4%. We have 22.591602, and then we just multiply the 550 into 22.591602. So the answer is 12,425.38.
Now, for final topic is all about general ordinary annuity. General ordinary annuity is the first payment is made at the end of each payment interval. Notation: C is the number of months in a compounded period. To know the equivalent month number, you need to know that compounded annually it has 12 months, compounded semi-annually it has 6 months, compounded quarterly it has 3 months, and compounded monthly it has 1 month. Key is the number of compounding period in a given payment interval. To solve for key, you need to divide the P to the C. P is the number of months in a payment interval. RA is the periodic payment of the present value of an annuity, while RS is the periodic payment of the amount of an annuity. The formula that we are going to use in solving general ordinary annuity for amount is S is equal to RS bracket 1 over SK at I bracket SN at I. If the K is fraction, the table that we are going to use is table 8. If it's a whole number, we are going to use is table 7. For S and at I, we are going to use table 5. For present value is A is equal to RA bracket 1 over AK add I bracket AN add I. The table that we are going to use in solving AN at I is table 6. Find the present value of an annuity of 1,500 every end of 9 months for 15 years if the interest rate is 6% compounded quarterly. But first, we need to identify the given.
The given for this problem is for R, we have 1,500, and for the rate, we have 6%. For the T, we have 15 years. For M, in compounded quarterly, we have 4. For P, or number of month in payment interval, we have 9 months. For the C, we have 3. In solving the I, we just need to divide the R to the M. In R, we have 6% divided by into the 4 for the M is equal to 1.25. The equivalent of 1.5 into fraction form is 1 and 1/2%. So the I is 1 and 1/2%. In solving the N, we just need to multiply the T to the M. NT, we have 15 years, multiply to the M, which is 4, is equal to 60. So in N, we had 60. In solving for key, we need to divide the P to the C. In this problem, the P is 9. So we need to divide the 9 to the 3 for the C is equal to 3. Following the formula in solving present value in general ordinary annuity is A equal to RA bracket E 1 over A key at I bracket A and at I. The table that we are going to use in solving for if the value of key is a whole number, the table of values that we are going to use is table 7. But if it's in fraction form, we use the table 8. 7 or 8. In this part, the table that we are going to use is table 6 because it is a present value. For the R, we have 1,500, 1 over A. Key, we have 3. Put down the 3. And I, we have 1 and 1/2%. Bracket. A. A. For the N, we have 60. I, we have 1 and 1/2%. Copy the 1,500. As you can see, our key here is the whole number, so the table that we are going to use is table 7. So we have 0.328383. In the second bracket, the table that we are going to use is table 6. We have 39.380269. In this section, we just need to multiply the 1,500 into the 0.323838 times 39.380269. We get the result of 19,397.72.